Thank you very much. Happy to see you, friends, colleagues, fellow Pythonists. It's an honor to be here, and I mean it, because I've heard about this conference for a while. I mean, I spoke with Philip many years ago, and I know that, I think he mentioned this is like a first or one of the first PyCons in Europe. So, happy to be here. That's finally done. Now, my name is Anton, and when I opened the attendee map posted on Twitter from this conference, I realized I'm missing, so I fixed it. I came from Munich, and although you see most of the destinations here have train icon, for me this luxury is not working, so I had to take a car and just drive. So I drove for 10 hours, and Google Maps made some jokes with me on the way. Like it took me on some weird road on the Czech countryside, probably just wanted to inspire me with the views of nice nature on the way for this talk. I don't know, but this is how crossing into Czech Republic looked like for me yesterday. I also got blocked on the way by some agricultural machines, as if they are reminding me who is actually producing the food here in this world. You know? So I liked it. It's like taking a break, a lot of time to think. It was a work day, it was yesterday, right? So I had to take some meetings, take some calls. So I just stopped casually near some trees to answer on my laptop, on my right. And some guy stopped in front of me as well, and he assumed that this is probably a common space for public toilet near these trees. So he didn't see me in the car, but thankfully these days meeting tools have a software like cutting out the background, so I was safe. It was good. So back to the map, you see next to Munich I have Bretzel, I have beer, and I have a Python logo. What does Munich have to do with Python, you might ask? Well, there are many talented developers, just like everywhere in the world, I guess, but we also have a community. We have PyMunich, which I started in 2015. We have conferences, we have meetups, we have many activities. So if you're around by any chance, or if you plan to be around, just drop me a message and I will tell you what's the next action there. You can find me on Twitter, and as long as my surname will not change, I will probably keep this username, Anton_Caceres. I'm not planning to marry or change my surname yet, so this should be safe. We also have PyLadies. We have PyLadies who actually promoted this conference to me. We recorded a video together promoting PyCon Poland, and they are nice, and they're all gender-friendly. So another nice meetup that you can possibly attend. Again, drop me a message. We'll organize that. Finally, there was one more thing wrong about this map that I believe. So I fixed it as well. I'm Ukrainian. I moved many years ago, but when I looked through the schedule, through the agenda, I saw many Ukrainian surnames. So, ta-da, now you have it as well. And since we are speaking about it anyway, cannot be silent about this. So this is my only conference this year, I assume, and it had to be Poland. I mean, there is a lot of support coming from Poland towards Ukraine, so thanks for that. Finally, wrapping it up. Anton from Munich, Ukrainian, we have a community, and I work at the agency that I created. We are small, but we do Python and many cool stuff that I'm going to present you right now. Back to the topic, workflows and processes. Let's start from the definition. Let's start from a big perspective. What is actually the difference between a workflow and a process? Anybody can help me with this? I have a motivation here. Slot number 1. And we are not allowed officially to drink in this building, so this is like a little present, and if you drink it, nobody is responsible for that, okay, in here. So, workflow and the process. Anybody can define me a difference, or I will do it myself. My opinion is subjective, so for me, the difference is just that the workflow is a well-defined process. When the process can be something abstract, like you need to do this and that, and then you get a result. When you get this really well described and formalized, then it's not a process, it's still a process, but now it's also a workflow, some steps that you can perform in order to achieve your goal. Now, there are many ways to describe a process, and some nations are especially good at it, like Germany, for instance. There, everything is a process, and sometimes you hit the wall, but still, the process is in place. I respect them for this, and maybe that's what inspired me to make this talk. We can describe a process with just words. We can say that the process, you need to, I don't know, go to the registration desk, grab your badge, go get a coffee, and then come listen to talks. We can also visualize it. Visualization helps because we are all human beings. Like if the process is complex, it's just way too long to speak about it. And we mainly hate audio messages, so if we would have to record a process in words, that would be probably annoying. So we invited these lots of ways to visually describe a process. Then, when we go in our daily jobs, we also have a lot of processes at work, also regarding the product that we are building as developers. Because actually every business is about the process. Would it be like a lemonade selling stand on the street? Would it be a big software company? Every business has a process, and we developers need to make this process run on some hardware. That's as I defined it. So we have to define process in the code, and oftentimes, honestly, it looks more or less like this. If we go naive approach, we just use a lot of if conditions, else statements. Like to be polite, I didn't show it. I screenshot this when you have like if, and when it goes after 90 characters that you cannot really see it anymore, so PyCharm marks it red, so I screenshot it, but I won't show it. But all of you saw it at some point of your lives, this ugly, nasty tree of ifs and elses. So this is one way to describe a workflow. Like, if this happens, do this. If something else happens, do that. But this reminds me the law of the instrument. Like when you have a hammer, everything looks like a nail. For us, a hammer is a coding tool that we have, so we just nail it. But there are other tools available, also for code, also for software developers. I will name one, the most popular one, Makefile. This is done specifically for that, to package things, to test things. You create a Makefile, it's a list of instructions. Maybe anyone can tell me any other tool that you currently use to run your processes. No, nobody wants, yeah. Very good, Taskfile. How about Airflow? This is actually the tool that I would like to present, but since this topic is cloud specific, it's not included. But Airflow is something I generally highly recommend. Like this is the tool, the open source tool that is out there, and you should read up that thing on the internet, I guess. But I will not present it today. Okay, we have some tools listed here. To me, reading it in the code still hurts. Like if I need to read a long Makefile, it's a de facto standard in Linux systems still yet. I wouldn't say it's ugly. It's just so complicated that our brains are not really designed to understand workflows like that. So let's jump back to the serverless and cloud scenario. I mean, why cloud? Why serverless at all? I will not annoy you with ugly charts saying how serverless is growing like hell. It's growing faster than the Pendolino train to Warsaw, in fact. I run an agency, so I see the demand of the customers. Like if 5 years ago it was just Python development, now it's Python and cloud, for us at least on the German market. So it is growing, and if you're not doing it yet, you will have to do it perhaps soon. We need to learn how to use it. Serverless comes with a lot of limits. It's cold starts, it's the execution timeouts, Lambda is 15 minutes. You cannot really run a long process or a long workflow within 15 minutes. If you need to do batch processing, it can take, I don't know, image recognition. If you have a chain of events coming in, you have to use another tool. You have to go beyond the limits of normal stateless serverless functions. And finally, why Python? What does Python have to do with this talk? Well, here I did include a chart because nobody believes me. Python is the most popular language in serverless functions these days. So most of organizations, if they're using serverless, they will be using Python. Close coming with Node.js, still leading. So finally, we are going to our topic, the cloud workflow orchestrations. So as you know or guess, there are tools designed specifically for that, to manage cloud functions in an efficient way, to build it in an easily traceable, reproducible, and maximally descriptive way. We have here our top three, well, from top three cloud providers, cloud workflow engines, which is AWS Step Functions, GCP Workflows, and Azure Logic Apps. I used pretty much all of them. They are very similar, yet they have differences. We will focus closely on step functions, and I will also show you examples and differences with the other two. And as I said, I don't mention Apache Airflow, but this is a very similar thing. Then there is Camunda platform, a German company actually. It's also good, but yeah, this is not in this scope. So let's start with step functions. As I said previously, with people, we are visual creatures. We like things visualized. It's just easier for us to understand and read in a makefile. So the easiest example of how can you use step functions is just to chain some functions together. You have function 1, working, done, the result is sent to function 2. Function 2 working, done, the result is sent to function 3, and so on. So, and this is already useful, because this way you at least go above the limit of 15 minutes timeout in Lambda. So you can now have 45 minutes if you have 3 functions chained together. Achievement. The next scenario is a conditional tree. So you have one function, and based on its result, if it's, I don't know, true or false, you get to the left branch or to the right branch. This is like standard things from algorithms, right? But there is just, it's not as popular in software development, I believe, at least before the cloud. It was not as popular to have these visual things, and they do have visual editors that I will show you in my demo in a moment, if the internet allows me, of course. So yeah, you can have a function, and based on the outcome of that function, you can say go either there or there. Then, important, exception handling. If one function goes kaboom, what do we do? And we can solve this not inside the function, but outside with just, it's usually JSON or YAML, just a descriptive language saying like, if this exception happens, do this. So similar to conditional, but you have more options to set up. You can say if this exception happened, retry, timeout and retry, wait, I don't know, with some backoff interval, try it again, and if then it doesn't work, then do the next function. Next one is manual approval. This is when a human has to be involved in the process. So function 1 is done, and function 2 needs a human to check it. It could be an order, or it could be, I don't know, maybe you need to check manually for some bank transaction to appear on account. Things are usually not really well automated. So you have a workflow, and you need somebody to check if money actually arrived. The person checks, click, and then the workflow continues. So this is also integrated. Can be in many forms. And we have parallelism. This is another great advantage, that usually when you define a workflow, in all of these tools, you can say, okay, I need this workflow to be done for the list of input parameters. And this can be chained. So one workflow at the end can have a list of results, not just one result. And it can call another workflow to pick one element from the list and execute them all in parallel, and then merge the results back together again. So this is similar to map operator in Python, but on the cloud scale. So it will launch, and you can of course configure, like if you want maximally 5 parallel processes, if you're hitting a limit of the database, for example. This is a typical use case. Cannot scale infinitely, of course, but it's under your control. Now demo time. Let's hope that my internet is still working. I need to kill the mirroring, or maybe I don't. Okay. I'm dragging this. Oh, okay. Can it be really seen? Yeah, it can. Okay. Good. We are in AWS Cloud Console, and we go to step functions. Here we have step functions, and I will show you. This is like one of our projects. I'm not sure. Let's try. Okay. This is a RDP machine, so it's a remote desktop. It's slow, but I'll try. So I made a workshop about this in PyDays Barcelona, but it took me 1 day to show it. So here I have really limited time. I will show you only the basics. I hope it's good enough. Okay, let's open up this one. So get ready. You will see the terribly huge workflow that I defined. Wow, that's it. So I will zoom it in to show you how exactly it's working. I will not go over all of it, of course, but just for you to understand. So obviously every block here is a step in the workflow, and usually this step is a Python function. Basically we are working around the way that we manage our code from the code, calling the code to this workflow orchestrator calling our code. So we start, we need to find some tasks. We are checking if the tasks are not empty, and then I'm running here a map operator. This whole green block means that this is run on the right. Yeah, here we have just 3 iterations, but it could be, 100 of them. So we do some steps in between, and these are just Lambda functions. If you click on this, like you see the source code of the step. Just Python code, as I say. So every step there, not every, but most of them is a Lambda function in Python. However, sometimes like here, check Athena CSV, delete, So this is not a Lambda function. This is a conditional that is integrating with other project of AWS. In this case, it's Athena. So here I'm checking if the query in Athena, and the query is really heavy, like it can take 10 minutes or so, if it's done. So that I could do it in Lambda, just in a loop, but that would be stupid. I would pay for Lambda execution to be just idling. So it integrates with all AWS products pretty much. So I'm not querying it actively. I'm using a spatial task block here that just asks, checks if the query is done or not. And this you can do for DynamoDB. You can have triggers, like when you insert something in Dynamo, or if there is a new file in the bucket, then the workflow is called. So this is more or less how it looks like. I won't go in details because it's a very straightforward thing. I'm creating here some tables, doing some data wrangling and packing it into Parquet format. I just show you that at the end, it just says, okay, we are done, and I can see all the messages on my way in the input here. So this lists everything that happened on the way, if I want it, of course, if I include it.
Does it? Yeah.
Yes. This is even better. Maybe it's planned like that. So when you start losing attention, I get louder. Who knows how to make PyCharm bigger? Command plus. I'll believe that. No. View, appearance. Where? Oh, beautiful. Thank you very much. Didn't know that. Good. So what I have here is a CDK. It's Cloud Development Kit. It's only available for AWS. It's AWS product. And this is a way, who knows Pulumi? Anybody use Pulumi? Some people use Pulumi. So Pulumi is a like cloud agnostic tool to manage different clouds. CDK is an AWS specific kit, a library that allows you to provision and manage cloud resources. So this is how I create the whole thing. This is how I create this whole step functions. You can do it in the web interface, of course, but if you want it in Git, if you want it all with the correct permissions, granular permissions, manageable, readable, controllable, you can also pack it like this in Python code. I will again not show you all of it. I want to say that this is the way I create a Lambda function, for instance. I just need a function name, I need a folder name, and then I say which layers, so libraries, will be included when this function will be packaged and uploaded to AWS Lambda. Memory size, our environment variables, that's it. So this is really just pure Python, and you don't need to be cloud architect to understand this, I'm sure. The same way you grant permissions, this is just a function variable defined here. You do SSM grant read, and it has a read permission on this prefix. The same way you have the bucket object instantiated here, and you grant it with the read-write permissions for this function. So it's really so simple. It's so much easier to read than the CloudFormation or Terraform, yet it still generates CloudFormation under the hoods, but you don't have to see that. That's behind the scenes. So yeah, Python when building and Python when using. Like, I think it's a good match for a PyCon, is it? Okay, enough of this. I don't have much time, so I go to the next one. How do I exit the presentation mode? I know hard way. Okay, good. Okay, we go back. Next, Azure Logic Apps. I will not show you the code, we don't have time for that, but I will show you how it looks and I will tell you the biggest advantage it has. So Logic Apps, I have them over here. Another project that I do has Logic Apps. This particular example is super complex, so you don't really need to read it, especially since it's in German. But these steps are similar. They're instantiating some variables, setting them. Now we'll go to the conditional part somewhere. Yeah, German project, as I say, they are good in doing processes. Okay, here we have some branching. Finally. More branching. I want to show the piece that I developed. This is a source of new customers, like a funnel. How do they treat them? What do they offer them? And this is actually a very smart thing here. I'll not disclose corporate secrets, but this way different teams can work together. A lot of different people can work together. And this is the piece that I developed, this one little thing in this crazy machine. What it does, this is just the HTTP request block. So all it does is it goes to this URL, it makes a GET request, it packs these parameters in the GET requests. I removed the code because it's a secret. That's it. And it sends the response down the stream. So this really little thing. However, think of that. In Azure, you do not need to write the code that will make HTTP requests. Like in Lambda in AWS, I would have to actually write a function that would use requests or something. It would go, it would fetch the results, it would send the results back to the workflow. The magic of Azure is that it has tons of connectors. And connectors are something that you can run inside these little blocks. It can do HTTP requests for you without writing any line of code. As you have seen, you just specify the parameters right there in placeholders. Works. Then you have like these many connections that integrate with all the products out there. And this is the only workflow engine that does it, from my experience, of course. So you can see eBay, Twitter, Facebook, anything. Say you want part of a workflow to post something on social media, you can have it. You want to get a trigger when you receive an email, then you run some workflow, you have it. You want to integrate with some complex CRM system, or you want to integrate with some enterprise CMS, SharePoint, Dynamics, or a non-Microsoft product, you probably have a connector to it for Azure. So for me, this is a silver bullet that Azure has. It integrates with everything, and it's a very rare case when you need to actually write the code. So it's visual, it's big, but it doesn't need the code. So people who are not developers can also create it, leave one little block for a developer and say, okay, and you do this. Good. Now, final piece, GCP Workflows. GCP Workflows is very similar to AWS. It doesn't have as many connectors as Azure. However, like this is the way the syntax is written. In this example, it's searching something in Wikipedia. It has more connectors than Amazon. It's just not as popular, I would say. So the killer feature of GCP is that there are products out on GCP that do not have analogs on Azure or on AWS. So for me, this is like honestly, the main reason to use GCP Workflows is if you use other features of GCP that would probably integrate with GCP Workflow, but not with AWS. So this is when I go for it. And this is how it looks like in the visual editor. It's just a screenshot, so I guess you don't need a demo for this. I took it from the internet. Yeah, so I think we are perfectly in 25 minutes. Then Thank you very much for your attention.
Thank you very much. And we have some questions for you. So let's start with the most liked one. How do you test a complex workflow orchestration like the one you've shown?
How do you manage?
How do you test?
You don't. It's a problem. So for AWS, you can test individual components of the workflow because it's a Lambda function. There are many tons of articles how to test Lambdas. What I did is I also wrote a wrapper script myself that when I need to test a sequence of workflow events, my wrapper is like AWS Step Functions, but childish mode. So it just takes it all on my local machine. It executes function number 1. It gives the result to function number 2. A very naive way, but this is really only if you're testing Lambdas. And if you're testing Lambdas, there are better ways to do it. This is like a very rare case when I need to check it in a chain, because most of the things there will be somehow using AWS-specific infrastructure. Let's say S3 or Dynamo. S3 is so popular, you probably cannot write a function not touching S3 or Dynamo or parameter store. Like even when your function starts, it probably needs to fetch some secrets from AWS, and then it will probably go to system manager and parameter store. For this, I use Moto. It's a library in Python that mocks AWS, and it mocks it on the level of network. So when you instantiate your AWS client, it would go to your local host instead of going to actual AWS. But again, this is not testing the workflow itself. It just lets you run it locally to some degree, isolating yourself from the world of AWS. So Moto is a good way to test AWS in general, but for workflows, you'll just have to, you'll need a test instance. It's very easy with CDK. You saw that instantiating, creating a workflow is just about creating an object in Python, so you can have it in a loop, while for environment in, and then you have a list like dev, test, prod, run that. And then you can use this like normal Python loop. You can put like minus and the environment name, and it will create you 3 environments instead of 1, and then you just test it there. For me, that's the only way. All right.
Okay, the next question. What about AWS SAM? Is it still relevant?
SAM, serverless application model. Or
I guess
yes.
So, yeah.
I'm not the right guy to judge if it's still relevant. I'm not using it. I'm not a cloud architect. I wouldn't call myself that way. In my project, I had plenty. No, it's a very exotic thing. But I would still not say that nobody's using it. So I think it's rather a question to some person from AWS advisory team than to me. Next one.
Okay, who is responsible for maintenance of the Logic App connectors?
Okay, so in context of Azure, of course, Microsoft is maintaining most of them. And of course, it will be mainly connecting to Microsoft products, as we all suspect. So these are reliable. Then, of course, there are community connectors. Microsoft wouldn't create so much of them, so the community connectors are managed by the community. So I think everyone can develop one, contribute, maintain. So mixed, 50-50, something like this.
Thank you. Can you use Git for versioning Logic App workflows, or you just use versioning on Azure portal?
Depends on the way you want to create them. If you want to make it fast, just using the web interface, then of course there is only a versioning available from the provider, like from Azure. If any, in AWS you don't have versioning at all. However, most of us use some tool like Terraform, Pulumi, CDK, CloudFormation. And this is a standard de facto that you would just have a Terraform files defining the workflow, and then it's of course in Git, probably in a separate Git repository. laying there. So yeah, and usually also with this is the way you will deploy it on some CI/CD. So you have your whole infrastructure in Terraform, including workflows, and then you push it, merge it, approve it, and then it gets deployed on staging, just like your code does. So we deploy the infrastructure and the workflow the same way we deploy the code. But you can still use a web interface, and this is advantage because you can also give it to a non-technical person to at least understand how this thing, visualize it. It will be much harder to explain a business process if it's just in code to a non-technical person as compared to when you have code and visual representation with all of these branches. So to me, it's a very clear advantage for business, have both. Okay?
Great. Thank you very much for the talk. And
thank you too.